Good morning, everyone. It's great to be here. Congratulations for this event. Actually, I was so glad to see that some hands rising of new people interested in this rising technology. I would like to tell you about QuantyMize, which is the leader in quantum accelerating algorithms. And actually, I would like to start from the beginning, which was a discussion between myself and Daniel Porat, the CEO. He is here. About, in general, what is quantum, and so I was telling him, quantum is superposition, it's not 0 or 1, it's 0 and 1, something like that, and he was telling me some other things, and then we saw something funny about the industry, the thing, so it's about binary thinking. What do I mean? Is that everyone says that in order to get some advantage, we will need to wait until we have 1 million qubit. Actually, there were even some talks right now. And that means that if you want to have some advantage, some utility of the quantum technologies, you will need to wait in the future. What we say, and I think it resonates very well with what Gal said, is that actually we can deliver quantum advantage or quantum volume, quantum value today. Okay, so how we do that? Think of the following metaphor. So you have a very nice mountain, you would like to get to the peak. I don't know, maybe Merutz LaMillion, right? So you can do it in two ways. Way number one is you sit there. Someone will pave a road for you, and then you will, with your new car, you will go up, and that's nice. Or you can do it in another way, which is to build your own 4x4 car, and that's exactly what we are doing at QuantyMize. So we don't want to wait until there will be a future million qubit, but we want to see what you can do right now. So what we do at QuantyMize for living is, first of all, we try to find problems that are very hard to solve or impossible to solve with classical computing, and they'd better be important problems. Okay, problem with a lot of value. We said money, okay? They need to be important problems. And luckily, in our very complicated world, there are many such problems that are very complicated and also very valuable. So finance is an example, and there are more I will tell you in a moment. So once we found that problem, we need to solve it. So how we solve the problem? We have something we call TLA. So that's 3 steps. T stands for transform. So you take the problem and you translate into the language of the quantum algorithm. Number 2, leverage. Leverage means that you have different quantum computers and you need to select the one that works the best for you. I would say that point number 1 and 2 is quite generic. I mean, any quantum company doing software will tell you the same. What is the special sauce? Our special sauce is actually the first step, which is to accelerate. Accelerate means that we need to use our resources more efficiently. So let's say instead of using a big number of qubits, we can maybe solve the same problem using less qubits. So that's one example of acceleration. And I will tell you an example right now. So this is the typical landscape of an optimization problem. So in the x-axis, you have how big your problem is. Okay, small problems on the left, big problems on the right. And on the y-axis, you have how many constraints you have. Okay, so how complex your problem is to be solved. And usually, nice models have like 1, 2 constraints, but real life problems, they have hundreds of constraints. So of course, you would like to be in the orange box. The problem is that at least if you work with our competitors, you will always be stuck here, okay, in the low left corner, not good. But if you work with us, through what we call the quantum accelerating algorithms, and one example is a proprietary algorithm that we call ECO, efficient correlated optimization, you can go from the green to the orange. Okay, so work with us. Let me tell you a couple of examples of what we've been working on right now. So the first 2 examples are from the energy sector. As you know, the energy sector is changing a lot in the last few years, and there are many new optimization problems that need to be solved. This is one example. So let's say this would be California, and then you can see this is the energy grid, and you can see a lot of orange and the red dots. So orange and red dots is bad. It means that these are the poor maintenance. So what you would like to do is to fix everything, but you don't have enough money. So you need to select so this is called risk management. And the problem is that you have many, hundreds of even thousands of units, and you need to select the one that are most critical to your grid. And for our customer, this is actually Noga, who you all know, it's in our POC, we were able to show how we can solve the same problem that they were solving before, but much faster. So they came to us and said, we know what the solution of this problem, not for California, of course, for Israel. We know how to solve it, but it takes us a minute. And a minute is a lot of time in terms of the planning of these systems, because you need to run it many times. So can you do it faster? Actually, we were able to do that. So we brought a problem that was solved in minutes into fractions of seconds, actually, hundreds of milliseconds. Application 2 is, again, in the energy sector. This is about the smart grid. Smart grid means that you have users, but also photovoltaic cells and also storage units that are all on the same grid. And this becomes a very complicated optimization problem. Again, with hundreds or even thousands of users, and you need to find the best way. Usually the constraint is that you have a problem that the grid that you're using, actually old grid, right? We put the photovoltaic cells on the same grid that was pre-existing and which was built just for customers. So this is a brings up huge optimization problems. And because we don't have much time, I won't give you all the details, but I just give you a couple of numbers. So we were able to demonstrate in our POC that we can, under certain conditions, we can increase the photovoltaic energy production up to 20%. Not only that, but at the same time, we can also reduce the number of charges and discharges cycles. Okay, so you have storage unit. The way to solve the optimization problem is that you have a storage units in the grid that sucks energy from the grid and then brings it back. So every time that you do it, if you do it many times, then you will need to buy new batteries. And as you know, batteries are very expensive. So if you can do less charging, discharging cycles, and in this case, we were able to reduce up to 50%, then you can use your batteries more. So this is not only more money, it's also more green. Good. So I've shown you a couple of examples. We were able to solve optimization problems faster for our customers and also better. So some some elements of the grid where their lifetime would be expanded up to 2 times. There is a third project we are working on. It's related to Mafat, so I won't tell you all the details. I just want to say that we are finding a way to solve optimization problems in real time, so really, really quick. In optimization world, there is always the trade-off between how fast you are and how good the solution is. And if you work with us, you will get the best of both worlds. So what's next? I mean, this is what we're doing right now, but of course we are a startup, so we want to grow big. And the way to grow big is that actually there is a problem in general that we are going to solve. And the problem is that you have on the left-hand side, huge optimization problem that humanity is trying to challenge with. And on the right-hand side, you have small quantum computers that somehow work, small-sized quantum computers. And as you can see from my slide, there is actually a huge gap, right? I think it's like, I don't know, maybe 1-2 meters gap that you need to cross between the optimization and the quantum computer. And what we are going to do is to solve those problems. So to connect these two worlds by our proprietary technology. So the way we do it essentially is that we have a QuantyMize intermediate representation. So we don't want to build up a new solution for each of these optimization problems. So what we do, we actually translate, these many real-life problems into a small number of classes, maybe, order 10, maybe even less. And then for each of these classes, we have algorithms that accelerated the solution of those problems in the quantum computer. So I would like to conclude with our motto, which is not about, we believe that the point is not about having 1,000,000 qubits, but knowing what to do with 1,000. If you have questions, we don't have time for questions. But there is a solution to that as well. You go to a website, and in the website there is a chat, and in the chat you can ask questions about our company. I'll let you know a secret. Whatever you write in the chat, we also read it. So I don't know. Don't ask what is the weather in Tel Aviv. Ask interesting questions so that they can help us. And also reach out. If you have a very cute and complicated optimization problem, reach out to us. And you have extra money and you don't know what to do with that, also reach out. Thank you.